Hi everyone! Today you'll be learning how to solve equations by factoring using the zero product property. So over the last few lessons, you learned how to factor polynomials, but you might have been wondering, what comes next? This is what comes next. So here is today's focused learning target. Given a quadratic equation, I will be able to solve it by factoring and applying the zero product property. Notice here we are now working with equations, so something equal to something, and notice also it is going to be a quadratic equation, so an equation where the highest degree is 2. So this new acronym, what exactly is this? As mentioned in the FLT, today we're going to be talking about this thing called the zero product property. So this is like the general format of a product. You have something times something equals something. For example, something times 3 equals 6. I know that it's going to be 2 times 3 equals 6. And then 4 times something equals 20. I know that it's 4 times 5 equals 20. So you guys are already familiar with what a product looks like. What if I have something times 6 equals 0? We know that the first number has to be a 0. And if it's 8 times something equals 0, we know that that second number has to be a 0. So this is actually what the zero product property is. So, if A times B equals 0, then either A equals 0 or B equals 0. So if something times something equals 0, then one of those somethings has to be 0. So let's take a look at our first example. We're going to solve for x using the zero product property. So notice here that I have a product. It's x minus 7 times x minus 3 equal to 0. So according to the zero product property, one of these is going to equal 0. So what I'm going to do is I'm going to draw a line to kind of split the two. So I'm working with two things. So on the left side, I'm going to set x minus 7 equal to 0. And on the right side, I'm going to set x minus 3 equal to 0. From here, it's stuff that you've probably seen in IM1. What a throwback! Woo! Right? So for the x minus 7 equals 0, we're going to add 7 to both sides to get rid of that minus 7, and we get that x equals 7. On the right side, we're going to add 3 to both sides. The minus 3 and the plus 3 cancels out, so we're left with x equals 3. So we have these two solutions. Either x equals 7 or x equals 3. And I know I kind of rushed through some of these parts, so go ahead and pause, rewatch as necessary. Like, go ahead and pause to process the information. Also, if we're going along what the zero product property states, basically the x minus 7 is that A part, and the x minus 3 equals that B part. Again, when something times something equals 0, one of the things has to equal 0. Right, so I have two solutions. It's either x equals 7 or x equals 3. Sometimes you might write it like this: x equals, and then like a bracket, 7 comma 3. So the stuff in the bracket is like all the potential solutions of x. One thing to make sure if you're writing it like this is to not use parentheses. Using parentheses makes it into a coordinate, and that's not what we're going for. So remember to use brackets, or you could just write like x equals 7 or x equals 3. I actually usually write it that way. This example on Edpuzzle is very similar to what we just did together. So please go ahead and solve for x using the zero product property. Alright, so another example, let's solve for x using the zero product property. So notice here it's 2x minus 1 times x plus 3 equals 0. So I'm going to set 2x minus 1 equal to 0 and also x plus 3 equal to 0. And now I'm going to solve for x for both options. So let's take a look at the 2x minus 1 equals 0 first. I want to get rid of that minus 1, so I'm going to add 1 to both sides. And I'm left with 2x equals positive 1. Next, I'm going to divide by 2 on both sides to get rid of that 2 right before the x. And then I'm left with x equals 1/2. Again, I'm kind of going pretty quickly right here, but go ahead and pause if you need more time. Next, we're going to look at the x plus 3 equals 0 option. So in order to get rid of the plus 3, I'm going to subtract 3 from both sides. Remember, inverse operations on both sides of the equation. And I'm left with x equals -3. So I have two solutions, either x equals 1/2 or 1/2, or x equals -3. Using the zero product property, I had set each part of the product to 0 and then solved for x from there. And I'm left with two options, either x equals 1/2 or x equals -3. So use the zero product property to solve this example on Edpuzzle. And remember, it's okay to pause and take your time. Go back if you need to process the information one more time. So for this next example, notice that we don't exactly have a product yet. So it's equal to 0, but it's not a product. It doesn't look like something times something equals 0. But recently, we learned how to factor using the method of exhaustion. And this is where it comes into play. Woo! Right? So I am going to use the method of exhaustion to factor this quadratic polynomial into products and set it equal to 0. And if you need a review on how to factor using the method of exhaustion, go ahead and look back on the YouTube video right before this. Alright, so x squared breaks down into x times x, only one option. And then the 3 breaks down into 1 and 3. Again, only one option. So right here, basically I only have one choice. But just in case, I'm going to check my work. So I'm going to write it out. X, I'm going to put x's on both sides. So x plus 1 times x plus 3 equals 0. Let's check our work. So we multiply the outer terms together to get 3x. And we multiply the inner terms together to get 1x. Again, we multiply the outer terms together and the inner terms together. And then we combine them. So 3x plus 1x. This equals 4x, which is exactly the middle term that's given in the original polynomial. So I know that we factored correctly. X plus 1 times x plus 3 equals 0. And now I can use the zero product property because I have this something times something equaling 0. So again, I have x plus 1 times x plus 3 equals 0. So honestly, it's this first part, the factoring using the method of exhaustion part, that'll probably take you the longest. But once you're able to factor correctly, this next part is, in a sense, just topics back from IM1. So I have x plus 1 equals 0, or x plus 3 equals 0. For the left one, I'm going to subtract 1, so minus 1 from both sides, and I'm left with x equals negative 1. On the right side, I'm going to subtract 3 from both sides, and I'm left with x equals negative 3. So I've solved for x, and I have two potential solutions. Either x equals negative 1 or x equals negative 3. So these are both solutions to this quadratic equation. Again, at first glance, this honestly probably looks like a lot of information. So go ahead and pause here and walk through the steps one more time. So we started with factoring using the method of exhaustion. And then once we factored, we used the zero product property to solve for the two solutions we get for x. And when you're ready, you can move on to the next example. Next example, again, we want to factor first using the method of exhaustion. So I have 2x squared plus 5x plus 3 equals 0. So the 2x squared, there's only really one option. I'm going to do 2x times 1x. And then the factors of 3 are just 1 and 3. So I'm going to write out the factored format with the two parentheses. So the two sets of parentheses, setting it equal to 0. So I'm going to go with 2x and 1x, so just x. Let's see. I'm going to try 2x plus 3 times x plus 1. And let's see how this goes. So I'm going to multiply the two outer terms together, which is 2x, and the two inner terms together. 3 times x is simply 3x. And I'll now combine the like terms. So 2x plus 3x equals 5x. And again, this is the middle term, the 5x, from the original equation. So I know that I've factored correctly. So I can now use the zero product properties to solve for x. So I have 2x plus 3 times x plus 1 equals 0. This is still the same as the original equation. It's just factored, so written differently. Right, so I have two options, either 2x plus 3 equals 0 or x plus 1 equals 0. Go ahead and pause here once and try to solve for x on your own. So for the 2x plus 3 equals 0, first I'm going to subtract 3 on both sides. Cancels out. I'm left with 2x equals negative 3. To get rid of that 2, I'm going to divide both sides by 2. Remember to divide both sides, not just one side. And I'm left with x equals negative 3 over 2. For the right option, x plus 1 equals 0, I'm going to subtract 1 from both sides. Cancels out, and I'm left with x equals negative 1. So now I have my two solutions, either x equals -3/2 or x equals -1. Again, I used exhaustion to factor the original polynomial and then use the zero product property. Please try this example on Edpuzzle. Remember to first factor using the method of exhaustion and then apply the zero product property to solve for x. For this next example, before you start, do you notice something is off here? So is there maybe a reason why I have to stop here before I even try to factor? So notice here that this equation is set equal to 2. So I can't use the zero product property yet because nothing's set equal to 0. So in order to use the zero product property, the equation has to be set to 0. So how do I get rid of this 2 on the right side? What I can do is subtract 2, so inverse operations on both sides. Notice here that I put the -2 right under the +7 because I can only combine like terms. I can only subtract a constant from another constant. So everything else actually stays the same. X squared plus 6x just pulls down, but then 7 minus 2 equals 5. And on the right side of the equation, I'm left with 0 because the 2 minus 2, so the positive 2 and the negative 2 cancel each other out. So now I can use the zero product property because I've created an equation set equal to 0. So before you even start a problem, make sure it's set equal to 0 so that you can use the zero product property. If it's not set equal to 0, then think about how you can move the numbers around so that it's a polynomial expression equal to 0. So now, first off, I'm a factor using the method of exhaustion. So I have x squared plus 6x plus 5 equals 0. So x squared breaks down into x times x. And then the 5, the factors are simply 1 and 5. So let me write out the general format. After you factor, you're going to have something times something equals 0. And again, I only have one option here. So it's going to be x plus 1 times x plus 5 equals 0. But just in case, let's check our work. So I multiply the outer terms. X times 5 is 5x. I multiply the inner terms. 1 times x is 1x. And then I combine it. So 5x plus 1x equals 6x, which is exactly that middle term we're looking for. So I know I've factored correctly. So now I can move on to the next step of using the zero product property. Right? So when I factored, I ended up getting x plus 1 times x plus 5 equals 0. Again, this is the same as the original equation we were given. It's just rewritten a lot more now. So I'm going to now set x plus 1 equal to 0, as well as x plus 5 equals 0. So again, I have two options. So for x plus 1 equals 0, I subtract 1 from both sides, and I get that x equals -1. For the one on the right, I'm going to subtract 5 from both sides, and I'm left with x equals -5. So these are my two solutions. x can either equal -1 or -5. And to check your work, you can always plug in x in the original equation and see if the equation works out. So this next example, notice that it's a polynomial equation set equal to 3. So remember, don't start anything until it's set equal to 0. So until the equation is set equal to 0, don't try to solve for x yet. So the next question is, how exactly do I get rid of this 3? How do I remove it? So since it's a positive 3, what I can do is subtract 3. But remember, you want to subtract 3 from both sides of the equation. Again, since we can only combine like terms, the 5x squared plus 11x just comes down. 5 minus 3 equals positive 2. So on the left side, I have 5x squared plus 11x plus 2. And the right side cancels out and we get a 0. So now we can start factoring. So let me rewrite it. We have 5x squared plus 11x plus 2 equals 0. So how does the 5x squared break down? There's only one option, 5x and 1x. And then how does the 2 break down? Again, there's only one factoring pair. So 2 times 1. The next step is figuring out which combination works. Again, if you need more practice with this, refer back to the YouTube video from earlier. So I'm going to try out 5x plus, let's see. So I'm going to try out 5x plus 1 times x plus 2 equal to 0. Let's see if that works. So I multiply the two outer terms. 5x times 2 is 10x. And then the inner terms, 1 times x is 1x. I'm going to combine like terms. So 10x plus 1x equals 11x. And indeed, this is the middle term we're looking for. So I know I factored correctly, and now I can use the zero product property to solve for x. So I have my product right here. So 5x plus 1 times x plus 2 equals 0. And from here, I have two options. So either 5x plus 1 equals 0 or x plus 2 equals 0. Again, you can pause right here real quick and go ahead and try to solve for the x's on your own. And then press play when you're ready again. So for the 5x plus 1 equals 0, first I subtract 1 for both sides. And so I'm left with 5x equals -1. Be careful about that negative. I'm going to divide both sides by 5. And I'm left with x equals -1 over 5. And then the second option, x plus 2 equals 0. I'm going to subtract 2 from both sides to get rid of the plus 2. And I am now left with x equals -2. So these are my two solutions for this equation. X equals -1 over 5 or x equals -2. Again, both of these are solutions to the original equation. Right? Please try this example on Edpuzzle. Remember, before you do anything, you want to set the equation equal to 0. And try this one out as well. Notice that the equation is set to equal -1. So how do I get rid of a -1? Be careful about that part. So just a few more examples. So notice here I have x squared plus 8x equals -15. So how do I make this equation so that it's set equal to 0? I want to get rid of that -15. So what I'm going to do is add 15 to both sides. But notice on the left side, this x squared plus 8x, there's no constant. So basically there's like a floating invisible +0. So remember, I can only combine like terms. That's why I didn't put the +15 under 8x or anything, because that'd be confusing. I put +15 kind of in its own little space. Imagine there is like an invisible 0 floating in that blank space. So instead of your name here in the blank space, it's an invisible +0. I don't know if anyone got that Taylor Swift reference, Alright, so the left side of the equation, I get x squared plus 8x plus 15. Then on the right side, it cancels out, so I'm left with a 0. And now I am okay to start factoring using exhaustion. I'm going to skip the process of exhaustion at this point. If you guys need more practice or need help, feel free to ask us during the Google Meet, or you can ask us on Remind, like, how did you guys do this? At this point, I'm skipping the factoring by exhaustion part just to save a little bit of time. And then here I have a product, so I'm going to apply the zero product property. So either x plus 5 equals 0 or x plus 3 equals 0. The two options. And here I'm solving for x. So for the first option, I get x equals -5. In the second option, I get x equals -3. So I have two solutions, x equals -5 or x equals -3. So I wanted to go over this example just to show you guys what it would look like if you don't have a constant term on the left side of the equation. But once you get over that part, the rest is pretty similar to what we've been doing. And then what if we have something like x times x minus 7 equals 0? It's actually still the same process. We can still use the zero product property, because notice that it's still a product. So x times x minus 7 equals 0. So what I'm going to do is I still have two options. Either x is simply 0 or x minus 7 equals 0. So the left sides are done. The left option, x is simply 0. Let's take a look at the right side, the right option. So I'm going to add 7 to both sides, and I'm left with x equals 7. So we still get two solutions, either x equals 0 or x equals 7. X equals 0 is still very much a solution, so please make sure you're writing down both solutions. And your last example is very similar to the example we just worked on. So just as a quick review, today you learned that you can solve a quadratic equation by first factoring it using the method of exhaustion and then using the zero product property. So whenever something times something equals 0, one of them has to equal 0. So if a times b equals 0, either a equals 0 or b equals 0. Great work today, guys, and be sure to submit your notes on Canvas.